All right, so your second lab for the semester is graphic motion, and it's pretty much like it sounds. You're going to analyze the motion of an object, right, by using concepts. So you're going to predict, you're going to graph it, and then you're going to match the graph to a curve fit. So you want to draw it. What are you drawing is position and velocity graphs, and the software we're going to use is Vernier Video Analysis. So let's take a little deeper look into the lab. So the first activity, you're going to make predictions about what the position versus time and the velocity versus time graphs look like for two different cases of uniform motion. Uniform motion means constant velocity motion. So the position will be changing with time for a constant velocity, which means that the acceleration should be 0. So to complete the predictions, you're going to need to sketch out graphs on a piece of paper. You're then going to take a picture of your sketch and upload it as a file to your Google Doc and insert it in the little box. It's going to be the same type of box as an essay question. If you have a tablet where you can draw on the tablet, you can do that as well. But the instructions are for the least common denominator of you're drawing on a piece of paper, you're taking a picture, and then you're uploading that picture. For every sketch that you make, you're going to need to describe your sketch, right? So there's an explanation part to each one of these questions. So you want to talk about, where it's starting, what the slope is it a linear curve, is it a quadratic curve, right? Use physics vocabulary if possible. So the predictions are the place in the lab where you're really trying to match up what you're learning in lecture to a real phenomenon that we can play with in lab. So one thing to know about predictions is you're not being graded if you're right or wrong. You're mostly being, because it's a guess, okay? You're being graded on if your sketch has all the required elements and your explanation describes your sketch. So I recommend that you use the checklist for formatting to get full credit on a prediction. And to show you what I mean by checklist for formatting, there's a section heading that says extra resources so you could be successful. In that section, there's student checklists for formatting. In this document, it has all sorts of checklists for graphs, for measurements, for calculations, and for predictions. So if you can go through and check off each one of these boxes, you can be more confident that you haven't missed something that's required in a prediction. Do the same thing for a graph or a measurement. So activity 2, we're going to collect data to match the two predicted cases. And when I say two predicted cases, they're pretty simple. In one case, you're moving forward at constant speed, starting at a particular location. The other case, you're moving backwards, you're moving to the left at a particular speed, starting at a particular location. So you need to take a video of yourself or some other object moving at this constant speed. That's the way you'll learn the most out of this lab. If you, for some reason, cannot take your own video, or you are having issues with a video that you were taking, there is a backup video, but as you can see, I consider the backup video to be pretty boring. You'll actually get more out of the lab. You'll learn more if you do the moving. This is actually pretty hard to move at constant velocity. So you'll just get more out of it. So you're going to upload that video to a program called Vernier Video Analysis. I'll kind of walk you through that in just a second. So this is a web-based program. You don't need to download anything. Our site license is embedded in the video, in the link in your Google Doc. Okay, so it's not something you need to download. There are links to help you in two different locations. The first place is going to be in the necessary equipment section of the lab, and the second place is on As You Learn for this week, there's resources for Lab 2 to help you. I'm going to walk you through that in just a second, but I want to say that you're going to need to have a known distance in your video so you can set a scale. Okay, you're going to be walking to the right, right? You're going to need to, in plotting position versus time, you're going to need to specify how much 1 meter is so you can have some way to say I've moved 2 meters in, 5 seconds or whatever. I guess that's a little fast, but you know what I mean. So I recommend that you have a 1 meter long object to use as a reference because it's big enough to see in the video. So if you have a tape measure, if you're using a tape measure, that's pretty straightforward. You just measure out to 1 meter and you put that down in some plane that's really close to where you're walking. So right behind you or right next to you, or you're walking right on top of it. If you don't have a tape measure, if you're using like the downloadable paper ruler that I gave you for the first lab, or if you've got, I guess a sewing tape will be fine too, but you can use a regular ruler and measure out 1 meter on a broom handle and just put tape on either end. So you know where 0 is, you know where 1 meter is, you put the broom on the floor and you walk in the same plane as the broom. So that's something that you will have to set the scale. So let me walk you through that video analysis. Like I said, it's the license for the software is embedded in the link, so you need to press that link. Okay, I'm going to pull the software over and kind of walk you through what you need to do. The first thing you need to do is, obviously after you've already taken your video, you're going to import your video into the software. So here's me moving to the right. I open it up and it tosses it in there, and there's me, and that was a long time ago. It was really cold, so I'm all in my sweatsuit and sweaters. So the next thing you're going to do is set that scale. So here's my scale behind me. Now I should have had the scale a little closer to where I was. I had it quite a bit behind me. So I'm going to, so my scale is probably going to be off a little bit because we're in a slightly different plane. If you think about a camera widens the further out it goes. So if we're in a slightly different plane, the camera sees a wider distance behind me than it is where I actually am. So I'm going to have to adjust for that. And it's going to cause error in my data. So regardless, I go over here, I need to set the scale. You see all sorts of things popped up. This 2 little buttons work to set the scale. I'm going to put that on either end of my cart track, and I'm going to say it's 1 meter. And then this is my Y and X axis, and here's my origin. So I'm going to put the origin at the end of that because the motion, you're supposed to start a little bit to the right of the origin. And then I'm going to check that my x-axis is level. So I have to tilt that a little bit until it's nice and level. So I've set the scale. The next thing I'm going to do is add data points. So I'm going to watch this go through a little bit, and what I can do is let me see, let me start, you know what, I'm going to start all the way at the beginning, and I'm going to add a data point. One thing I am going to do is change how many frames advance to make it easier. I'm going to advance 5 frames. Okay, so I'm going to kind of pick a point that's on my x-axis, that's kind of in the middle of my body, and I need to keep that same data point. And you'll notice that after I clicked, it advanced all on its own. Now I'm going to pass that one. There we go. I'm going to add another data point and another data point, so on and so forth. I should have done 10 frames. Now you'll notice, I'm trying hard to kind of click on the same point. It's a little bit difficult. You'll notice over here, it's already graphing position versus time. Okay, But let's say I'm done there. This data point over here isn't in the same line as the others. So I'm going to get rid of it. So I'm going to go to Edit. I'm going to click on that first data point and I'm just going to delete it. And now it's not even part of the system anymore. A few things you want to notice is we want to plot position versus time. One of your graphing checklists is to make sure that you have your axes labeled properly. The way to do that is in these columns. This is your X column data. This is your Y column data. You can click on that and you can just change and it shows up right in your graph. Now my Y data is pretty boring because I'm not moving in the Y direction, hopefully. So I can actually just turn that off. Okay. A few other things you're going to need to do is on your graph, you're going to need to edit graph options. You can add a title. Look, I have some already there. And the other thing you're going to need to do is set the scaling to 0. We don't always have to set it from 0, but in this particular case, we need to show what we need to see. Okay, so after we have our graph, we're going to need to export that to our Google Doc. So you go over here, that's the little file icon. You're going to export. There it is. And it's exporting the graph. You can change some labels, right? And then you can save it. Okay. So it's pretty straightforward. It's pretty easy to use. I'm going to chuck that back over here. Okay. So one thing I wanted to let you all know is that it's pretty difficult to move at constant velocity. So it's okay if your acceleration isn't exactly 0, and your velocity is maybe a little bit jerky. It's not necessarily constant. It's okay, okay? You can always talk about better ways to do the experiment in your conclusion and causes for experimental error. So don't get hung up because it's not perfect. Just get some data, move forward. The other thing, so activity 3, we're using your graph from the Vernier video analysis to do curve fits on that graph. And from those curve fits, we're going to determine the initial position, the velocity, and the acceleration. You have 2 videos that you're taking, but we're only doing the curve fits on the last one, okay? You won't gain anything more by doing it twice, so we're just doing it the once. So let me bring the software back over again real quick and show you how to do those curve fits. It's again in these graph tools, apply curve fit, and you choose what kind of curve fit. You're going to apply 2 different kinds of curve fits to 2 different types of data, a quadratic and a linear. We'll go ahead and do the linear. It's pretty easy. And then one thing you should know is that you may need to move this around so you could see things properly. Okay, so pretty straightforward. If you have any questions on this lab, you can contact your lab instructor. The preferred method is through the questions forum for this particular lab. However, you can also email your instructor directly using the instructor contact information posted at the top of the As You Learn page. In this instructor contact information, it lists for each section who the lab instructor is, their email, and it also has a link to a Google form you can use to set up a one-to-one meeting if you need to. Thank you for your attention, and let us know if there's anything we can do to help.